Okay, seems like nobody has any questions. So we'll just get started with the questions that I have for you guys. Okay, so these are all questions from past tests, past exams. So if you're wondering what kind of questions are we going to be asked in the test, here is a sample of some of the questions, the way that they are asked. Usually on this section with population, samples, sampling methods, most of the questions are multiple choice. The majority of the test, which is on calculations, is on the chapters that will follow. But for this one, mostly multiple choice, just testing your knowledge. Do you know what the question? Okay, so if you don't have a question, please just leave your mic muted. Okay. All right. So in the video, I talked about probability sampling methods. I said that with probability sampling methods, everybody in the population has a chance of being selected. So nobody has a zero chance of being selected. There are four types that I mentioned: the simple random, the stratified, the cluster, and the systematic. So let's just quickly go into these questions. The first one says, I hope you've all seen this exercise. I posted it quite some time ago, so you should have had some time to go through it. And now can be like a discussion. It shouldn't just be me talking the whole time. Okay, number one, when the population is divided into mutually exclusive sets and then a simple random sample is drawn from each set, this is called what? Is it simple random, stratified, cluster, or systematic? Does somebody know? Anybody? I think these recordings will include a lot of moments of just silence where I'm just waiting for people to say something. Is anybody there? Or it's just me today?
We're here, ma'am. And
Okay.
I'm gonna be honest, I only went through the video once. I didn't thoroughly go through it yet. My apologies.
No, that's fine. I think I gave it to you guys. I don't think you'd have had time to go over it more than once. Okay, so for this one here, it says the population is divided into mutually exclusive sets. Now, a mutually exclusive set or mutually exclusive means that there are no intersection. Nobody is in, no element, no person is in both groups. So you could have something like male, female, first year, second year, and so on. So these are mutually exclusive. Now, if you remember simple random, that just means you have a list of everybody and then you say, I want 10, you put names in a hat, you pick 10 names out of that. Stratified, this involves groups. So this is maybe the answer. Cluster also involves groups. So this is maybe the answer. Now, systematic means you are following a system. So you have 100 people, you want 10 people in your sample. You can say 100 divided by 10 is 10. Then you pick a random person between number 1 and number 10, let's say number 2, and then next you'll pick number 12, then 22, 32, and so on. So what I'm doing to the first person I picked is I add 10, which is the 100 divided by 10. Okay, so this one here, number 1, this would be a stratified random sample. Now, the reason this is stratified instead of cluster is because with cluster, what we do is we do have mutually exclusive sets, but we also randomly select the clusters. So first we will randomly select the clusters and then select within the inside the clusters. Unlike stratified, where we just randomly select, we will use each and every single stratum. Okay, so with stratified, we will use each and every single stratum and then just randomly select within the stratum. Unlike cluster, where we will randomly select clusters and then randomly select inside the clusters. Okay. Then number 2, a marketing research firm divides the population of a state into geographical areas and randomly selects some of the areas. So you need to read these. I think I gave the answer away when I was talking about number 1, and then randomly selects some of the areas and takes a simple random sample of each selected area. This is an example of. Okay, so this one is an example of cluster random sample. Okay, because like I said, stratified and cluster involves groups dividing into groups, but stratified, you use all the groups. You must have a representative from each of the groups, but cluster, you are just picking groups and then you will go inside those groups to pick a representative. Okay, so stop me if you have any questions or anything is not clear. I see when I ask people to contribute, they don't want to, so I'll just answer them myself, I guess. A manufacturer of contact lenses is studying the curvature of the lenses it sells. In particular, the last 500 lenses sold had an average curvature of 0.5. The population is, so this is what we did on Monday, identifying what the population is. Okay, so the population, is it the 500 lenses? Is it 0.5? Is it the lenses sold today? Or D, all the lenses sold by the manufacturer? So when we want to, yes, go ahead.
The answer would be D, all lenses, because that is the population.
Okay, very good. So the population here is what we are studying. So the manufacturer is studying the curvature of the lenses it sells. So the population is, what are you studying? What are you trying to get information on? And they're trying to get information on the lenses they sell. That means all of them. Now this 500 lenses over here, that is the sample, because this 500 forms part of all the lenses that they sell. Okay, thank you for that. Number 4, a researcher is studying students in college in California. She takes a sample of 400 students from 10 colleges. The average age of all college students in California is that a statistic, a parameter, a median, population?
I would say it would be the median.
I think it says the average age.
Oh, you're right. That would be the statistics then?
The average age of all. Okay, so what we need to do. Yeah, go ahead.
If they are Okay, a researcher is studying students in college in California. She takes a sample, okay, of 400. All right.
Yep.
Okay, that's just a sample. And the average age of all students. Okay, I'm confused with this one. Are they referring to all of the 400 or just no? Right.
The question is saying the average age of all college students, is that parameter, statistic, median, population. Now this here would be a parameter. Okay, so this is why you need to read the question and understand, because I believe this may be one of those questions where they try and trick you. Okay, it's not that tricky, but anyway, so here when it says the average age of all students, because look at what she's studying students in college, and what do I have? I have the average age of all of them. Now, the population in this case would be all the college students. So the average age is a parameter. So remember, P for parameter, P for population. Okay, so it's not. Okay, so it's not a statistic just because the researcher is mentioned. Okay, right. So this number 4 is a parameter. I hope that's what the rest of you also got. Right. Number 5, statistics and parameters. A are both used to make inferences about X. B, describe the population and the sample. Read the word respectively. Describe the sample and the population respectively. Describe the same groups of individuals. Okay, so we know it is not A because statistics come from samples, parameters come from populations. So if I know the average age of all NUS students, I don't need to make any inferences, because we make inferences from a sample to a population. We take a small group and then we extend it to everybody. That's why we use statistics. So if I know the parameter already, I don't need to make any inferences. So here it's not A. Then D, describe the same group of individuals. No, this is definitely not true, because we said S for statistic, S for sample, P for parameter, P for population. So a sample and a population are not necessarily the same. A sample is taken from a population, so it may be a smaller group of the entire population. So A and D are out. And then B, describe the population and the sample respectively. It is not B, because when it says respectively, it means statistic goes with population and parameter goes with sample. That's what the word respectively means, which is not the case. So this C must be the correct one, because statistic and parameters describe the sample, which goes with statistic, and parameter, which goes with population respectively. So S for sample, S for statistic, P for population, P for parameter. Then, okay, I think these are 2 questions that I got from 2 different papers, but they're phrased a little bit different. So number 6, I'm not going to do it. It's similar to that one, but the answers are not the same. So I hope you'll be able to work that one out. Number 7, suppose we sample by selecting every 5th invoice in a file after randomly obtaining a starting point. So your mind should already click when you hear every 5th invoice. That means every kth something after randomly obtaining a starting point. What type of sampling is this? This is systematic, because that's how systematic. We have a system that we are following. So when we follow a system in choosing our sample, we are using systematic random sampling. Then number 8, which sampling method is used to obtain or draw a sample that accurately reflects the characteristics of the population. Okay, so in the video I made, I didn't talk about quota, purposive, and snowballing. Okay, but I can briefly talk about them. Now, quota sampling. This is a non-probability random sampling that is done. Now, the way this works is, let's say you've decided you need a sample of 1,000 people. Instead of using the random, the probability sampling techniques that we talked about, what you do is you can just sit maybe at a mall and then just ask anybody who's coming, please, would you want to fill in this form? If they say yes, you give it to them. If they say no, you continue until you have 1,000 people. That is a quota. So you're trying to meet a quota. So you say, I just need to get 1,000 people, or I just need to get this many people. So you're trying to get a quota. Now you can see there's no way to really tell if this represents the population that you're interested in, because you're just saying, I need this questionnaire filled in or something like that. Okay, so this is an example of a non-probability sampling method. Purposive, here you have a purpose. It is also called judgment sampling. So when you see judgment sampling, you see purposive sampling. They mean the same thing. Here, what happens is the researcher uses their judgment to pick the people that they want in their sample. So they think, okay, yeah, this person is probably going to give me the information that I want, so they go to them. So you can see it's not really random. So this may come in where, for example, you're doing medical research. So you're not going to say, okay, I'm not going to go to Vernhill and ask people about this. Let me rather pick this doctor, pick this doctor, pick that one. So the researcher is using their judgment. Okay, now random sampling. This would be like simple random sampling, which we did. Now snowballing. This is an interesting one because this deals with usually sensitive issues where where populations are not out in the open. Let's say, for example, you want to interview why people go into prostitution. Most people don't advertise that, hey, I'm a prostitute. Most people don't do that. So what you would do is maybe somehow you would identify one prostitute and then you would ask them, okay, do you know any others? So they could refer you to somebody else, and then that person could refer you to another person, and so on. So this is usually with sensitive issues. Maybe another issue could be people who deal with drugs. Most people, again, are not out in the open advertising it. So you identify one and then get referrals. So it's like a snowball. I think you've seen in movies or somewhere where a snowball is rolling down a mountain. As it goes down, it just gets bigger and bigger. So it's like a snowballing effect. So this quota, purposive, snowballing, these are all non-probability sampling methods, which I will make a video of and then send it to you guys, but they do not accurately reflect the population usually. So the answer here would be random sampling, because random sampling, you know what probability any element has of being selected or not being selected, and you can make sure your sample reflects the population, unlike these quota, purposive, and snowballing, not really. Okay, number 9, what is a parameter in statistic? Is it the mean, the measure computed from the population, P4, parameter, P4, population? Okay, so is it a standard deviation, a measure computed from the sample? So here, mean is not the correct answer. So A parameter, a mean can be a parameter, yes, but you must always choose the most correct answer. A standard deviation may be a parameter, yes, but always choose the most correct one. So the most appropriate answer here is that it is a measure computed from the population. So P for parameter, P for population. Number 10, which of the following is not a type of sampling? So here, quota, I've mentioned it before. It is a sampling. Cluster is a sampling method, and multi-stage is a sampling, because we can think of cluster like a multi-stage sampling. So you do it in 2 steps. First step, you are selecting your clusters, or which clusters you want to be part of your sample, and then you go inside the cluster. Okay, so the answer number 10 is A. Effective sampling is not a sampling, is not a type of sampling. Number 10, which method is most likely to produce a random sample of the members of your class? Is it A, listing the first 6 people that come to mind? Probably not, because if you list the first 6 people in your class that come to mind, you'll probably list your friends. So if I'm doing an opinion poll, usually you and your friends think in a similar way. That's why you're friends. Okay, choosing the 5 oldest students in class, probably not. Writing the name of each student on strips of paper and then drawing these slips from a hat, absolutely. So the answer would be C, because that is simple random sampling. D, selecting the first students to arrive to class, not so much. So the correct answer is C. Number 12, which procedure likely to obtain a statistical unbiased sample? So when we say unbiased, there must be some probability sampling technique somewhere used there. So it shouldn't be like a quota, snowballing, and something like that. So surveying a random sample of employees from a list of all employees. Okay, maybe this one is starting to stick out. What other options we have? Inviting all employees to indicate their choices by email. This one, I doubt it. Most people don't like responding to emails. So probably not B. And placing suggestion boxes at random locations. Now these suggestion boxes, these are usually filled in or by people who have something to say. So they're angry or yeah, so probably not. And then assembling a group of 1 member from each department and recording the preferences of these employees. Okay, this one is closer, but I believe A here, surveying a random sample of employees from list of all employees. That would give you the best chance of not having any bias. Okay, then number 13. Number 13, the purpose of statistical inference is it A, to collect sample data and use them to formulate hypotheses about the population? I'm liking this one because that's what we do. Let's see what else we have. To draw conclusions about populations and then collect sample data to support the conclusions. That doesn't seem very scientific. You don't usually decide on something and then you look for evidence to fit into what it is you found. So it's usually the other way around. You find data and then you analyze it and say, okay, this is what the data is saying. Otherwise, you say, okay, this guy is bad. I'm going to look for all the bad things about this person. And then we'll know. It's the other way around. Find bad things about the person, then conclude that the person is bad. Okay. C, to draw conclusions about the populations from sample data. Okay, I'm liking this one even more than A because I'm not collecting data anymore, but I'm drawing conclusions about the population from a sample data. And then to draw conclusions about the known value of a population parameter. No. Okay, so if you know the population parameter, there isn't much that you need to do. Okay, because what you do is you have a sample, and then from there you want to extend that to the population. So the correct answer is C. Then number 14, suppose we sample by selecting every fifth invoice in a file after randomly obtaining. I think this is repeated. It's like one of the questions I answered already. So this one is systematic because, like I said, you have a system or a way that you are selecting uh, an element to be part of your sample. 15. What is the best sampling technique to use when determining the average speed of cars on a section of the B1 highway? Is it simple random, convenience, systematic, A or B? Okay, so here I'm not liking simple random because simple random, you need a list of all the cars. So usually if cars are just going past, I don't think the police with their scanners have a list of all the cars that are going by. So I don't think it'll be simple random. Convenience, you can use convenience. Maybe you wait there at 5 o'clock because I've seen police, they're not usually there like throughout the day. When I drive past, I see them in the afternoon when people are going back home, or early morning when people are going to work. And systematic, this one I like as the answer because you are selecting cars. You can say, okay, I'm going to collect the I'm going to read the speed of every fifth car that passes by. Okay, so that might be a good one. Okay, and number 16, the Office of the Registrar wants to find out which courses students consider to be of the most benefit to them. Which procedure would be most likely to produce a statistically unbiased sample? Is it asking students to mail in a questionnaire? Usually not. The people who usually mail things back, they're angry about something, they want to report something, so probably not. Surveying a random sample of students taken from a list of all students. I'm liking this one because you have the list of all the students, and the Office of the Registrar would have a list of all the students, and then they can pick from those. C says surveying the first 100 students on an alphabetical list. I don't think that is that will produce some bias. It's not as good as the previous one. So C is, yeah, at least you're picking them from a list, but it's not as good as B. And having students complete a questionnaire on a college website. I think most people don't like doing questionnaires, so that might not be the way to go. So for 16, the answer is B. Okay, so I just want to do number 17 and 18, and then number 19 and 20. Those involve you guys doing some thinking, answering them in your own words, so you can answer those. Number 17, the group of individuals who have a chance of being selected for a survey is called a sampling frame. So that list where you take your sample from, that is a sampling frame. So when you're asked what is a sampling frame, it is just the list of all, it's the list of the entire population. Then number 18, the set of all individuals who belong to the group being studied by a survey. So we've moved from a population. Now we're looking at those that we are studying. That is our sample. Okay, so I see it's already 8 o'clock. Some of you mentioned that you have a class coming up. So I will stop here for now. Do we have any questions? Or is that fine? I hope I was loud enough. I was told I'm speaking softly.
When can you post the next video
Sorry?
to talk about? When are you going to send the video?
This one?
No.
Which video?
You said you were going to talk about the one with the quota sampling.
Okay, that one I will do before Monday. So it'll probably be part of next week's class. So just at the beginning of it. Yeah.
Thank you, ma'am.
Okay.
Good evening, ma'am.
Hello.
Good evening, ma'am.
Oh, I can hear you.
I have no question. Okay, actually, I do have a question. If
Mhm.
it is possible for you to do a bit earlier for us to go through it and make our own notes so that we can also be able to participate.
Okay. I think for Monday, I will do my best to do that.
Okay, thank you, ma'am.
All right. Any other questions, suggestions? Okay. If not, I will see you guys on Monday. Have a good evening.
Ma'am.
Bye.